Hi kids, it's me, I'm back. Did you miss me? See, the correct answer is no, Mr. Gilner, but we're gonna pretend we missed you to make you feel good about yourself. That's the correct answer. Another great day in Earth and space. What are we gonna learn about today? Stars, a little bit more specific about stars themselves. Not their whole life cycle, but why are they bright? Which ones are brightest? Which ones are hottest? Which ones burn their fuel the fastest? And so forth and so on. So, I'm not going to be given a test, obviously, next week like I was supposed to. We're going to go over that material, but there's going to be a little bit of a quiz at the end of each week, 5 or 6 questions maybe at the most. And I'm going to add them all up together, make a test out of it, make a test grade out of it. Except it's going to be a quiz grade. It's not even going to be an actual test grade. So, and y'all don't have to worry too much about big test grades in here or projects for now. So, stars. Why are they different from each other? How are they different from each other? How do we describe them when we look at them in outer space? Let's start with blue, white, yellow, orange, and red. What's the difference between a blue and red? So the hottest are the blue ones, and the brightest are the blue ones. So the blue ones are the hottest and the brightest. So what are the red ones? Well, the coolest and the dimmest. Surface temperature for the sun, 10,000 degrees. Surface temperature when it becomes a red giant, 7,000 degrees, 5,000 degrees, it's going to be a lot cooler. When it was blue, it might have gotten up to as much as 15,000 degrees on the surface of the sun when it was blue. But it's not blue anymore. Now it's in the yellow stage. So it's in the middle age stage. It's halfway through its lifespan. It's 5 billion years old. It's going to live another 5 billion, and at that point turn red and become cooler and larger. So the blue ones are smaller, brighter, and hotter. Then the white ones are a little cooler than that. They don't expand much, but they're a little cooler. Yellow, a little cooler than that. Orange, a little cooler than that. Red, a little cooler than that. So you like a difference of 5 to 10,000 degrees from blue to red. And so blue is brightest, blue is hottest, red is coolest, red is dimmest. But the hard part about dimmest is the numbering system is inverted. Like the brightest ones are the low numbers and the dimmest ones are the high numbers. And so star brightnesses, let's talk about that for a minute. It's not actually called brightness, it's called magnitude. A star's magnitude has 2 different possible magnitudes. Its apparent magnitude is how bright it looks from the Earth. And its absolute magnitude is how bright it looks compared to the other stars if it was 10 light years away. See, that's the one that gets people right there. Right there, yeah, that'll get you. That's a tough one. So, apparent magnitude, pretty easy. It looks bright or it looks dim. Apparent magnitude, pretty simple stuff. Sirius, the brightest star in the sky, not very big, but it's real close. But the closest star to us, Proxima Centauri, Alpha Centauri, the Centauri system, those are the closest stars. They're not the brightest. They're dimmer than Sirius. Sirius is brighter than they are. Apparently brighter. It's not a big star, though. There are much bigger, much brighter stars out there, but they all look dimmer because they're far away. So, apparent magnitude, pretty simple stuff. It looks pretty bright or it looks pretty dim. That's about it. Apparent magnitude, how it appears from the Earth. So now, absolute magnitude. It's a little different. If you take every star in the universe and put it 10 light years away, set it all at the same distance from us, and then compare each one to each other, how are they going to look? What's going to be the brightest star? Well, it's going to be a blue supergiant. It's going to be the brightest star out there. What's going to be the dimmest? Red dwarf stars are going to be the dimmest ones out there. That's just, for absolute magnitude, your higher numbers are dimmer, and they are going to be your red stars. Your lower numbers are brighter, and they're going to be your blue stars. And giant or main sequence, that brightest is blue, hottest is blue. Dimmest is red, coolest is red. What else? Again, absolute magnitude is a comparison of the star's brightness if it was 10 light years from us and compared to all the other stars. What else do I want you to know about stars? The ones that live the longest are the smallest. The sun is going to live 10 billion. A red dwarf that's about to go nova and die out, a red dwarf smaller than the sun, might be as much as 20 billion years old. So the smaller they are, the longer they live. The larger they are, the shorter their life. And that makes sense because the smaller ones don't have as much area inside the star to fuse hydrogen into helium. So they're fusing less hydrogen into helium. But the big stars, the really, really massive, the hypergiants, might live 10 million years, not billion, with an M, million. The biggest stars live millions of years. The littlest stars live billions with a B, billions of years. I'm going to put a B right there. That's where the B is going to be. Maybe it'll be over here. I never know until I put it up there. And so I can put it wherever I want. I'm just too lazy to move it where my finger's pointing. That's my problem. So big stars, short life. Little stars, longer life. I mean, what else can I say? The bigger stars blow up as supernovas, the little stars novas. The big stars might make a neutron star when they die or a black hole. The little stars are going to make a white dwarf. After billions of years, and it hasn't happened yet, but it might one day, white dwarfs would turn into black dwarfs. Let me double check and see if I missed anything. Let's see. This information. Yeah, that's pretty much the whole lecture for the week. If you have trouble with this week's assignments, watch all 3 videos. The assignments come from all 3 videos. They are not just from this video. This video is just kind of to sum up stars in general and kind of leave it at that. I'm going to add a little bit more to this video, but not about stars. I'm going to kind of show you what life around here is like right now because this place is so empty. It's just weird how empty this place is right now. I have seen one teacher and the secretary today. That's pretty much it. Yeah, I'm thinking about taking this here green screen back to my house and just videotaping from there. You get to see me in my pajamas because actually these are my pajamas. I wear my work clothes to sleep so that I don't have to change when I get up in the mornings. That's a lie. Y'all know I don't do that. That would be weird. Anyway, all right, I'm going to try and get another video attached to this one that's to kind of show you what life is like around here right now. Right, kiddos, so what we're going to do today is a little safari, and we're going to go out into the hall and try and find some things. Really, it's a quest. We're going to go and try and find the rare and elusive employee because there's almost no one here. So there you have the classroom as the son, my only son. I'm still proud. He's gassy and blemishy, but I'm still proud. The solar system, right over there. Tranchilon, he's right there. And of course, the whales. And then over here we have, oh, there's Einstein. Don't forget about Einstein. You guys love Einstein, don't you? Okay, here we have it. Here we have my lab. Let's go look in my lab and see what we can find. Oh, it's a bit dark, but that's all right. We can see well enough, yeah. I think. No, that's pretty dark. Right? Oh, the hallway. Let's look in the hallway. This is the hallway outside my lab. There's nothing there. The lights aren't even on when I'm here. There's no one around. The only other person in the hallway is next door, and he's at a meeting right now. I can't go interrupt him, but we can go peek in the door over there. Let's go look over there. Go see if he's still in his meeting. There's your posters. You did a wonderful job on those. I think he's done with his meeting, but let's not disturb him. He looks like he's busy at work. We'll go down the hallway now. How's my accent so far? Am I doing all right? I'm not actually from Australia. I'm from Texas, which is the same thing but in a different continent. Oh, the lights came on. Did you see? The lights came on because they knew I was scared and they wanted me to feel more comfortable. Let's see. Let's hurry along a little bit. Quicken my pace a bit. Here we have the EF stairwell. Oh, look at that, the outdoors. I've seen the outdoors before. I think I've been out there once, maybe twice. Let's look over here. Yeah, there's the canopies. Everybody likes the canopies to keep the sun off of you at lunch. And the stairway. Look at the stairway, it's still here. Here's the Jaguar. I can't even breathe, I can't go down the stairs. I'm way too old for this. There's a Jaguar. Now, if this was British, it would be Jaguar, but this is Australian, so it's Jaguar. Let's see here. Oh, another dark hallway. Let's go see if there's anyone around. Oh, don't see anyone down there. Oh, don't see anyone down there. That's really dark. Let's go. Oh, the lights came on. Look, they didn't want me to feel scared. Yeah, let's put this on. That was British, not Australian. I'll have to go back and fix that one. And here we have the upstairs. And there's the doors to the cafeteria. More over there. This is where half of you go vaping. The other half is over by. Let's go out this way. This looks like the welcome center out here. See what we can find. Here's the library. The librarian's been working hard trying to get us to, say hi to the teachers. That's the welcome center. Let's go out this way. The cafeteria doors. There's the gymnasium. Let's go take a look at the gymnasium real quick. The Jag Shack, where you can get your Jag swag. There's the gym. Behind those thingies over there. Cafeteria. All the way, no, oh well, too bad. Maybe if I walked a little bit slower, but not going to happen today. Here we have all the dinosaurs. See, when the lights go out, these actually move and run around, killing each other. And then, of course, the next day they're back. Right where they were before. Let's go see what's down here. These lights are already on. I wonder why. Maybe somebody walked through. Maybe they've just been left on all day. Oh, I don't know. Or all week for that matter. Yep, oh, everything's lit up down here. They must like the people on this floor. People on the next floor up, they don't like us so much. There's your parking lot for your little cars. There's nobody there. There's one truck, but I'm not going to show you that because I want it to look empty. So there's nobody. Look at that. There's nothing out there. Crikey, it's deserted. It's interesting. Here's where everybody goes when they ask to go to the bathroom. This is, yeah. Why has it got anything in it? There's nobody here. So strange. Of course, nobody would buy it if those prices anyway, but there's the So there you have it. I mean, there's nothing going on here at all. I've gone completely bonkers trying to find people to talk to. There's no one here. It's gotten to the point where I'm talking to myself in stupid accents just to kill time. It is so weird.